So I'm very, very happy that Baml went first because we agree with them on so many things. Like the way that TypeScript has changed the way you write code is brilliant. We love our developer frameworks. We love how much easier that makes our life. And we are kind of sad that that doesn't exist everywhere in computer engineering. So me and my team, I'm Joj, I'm in product and AI here. Nico is our CTO, and he sadly could not be here because his wife is unwell, but I'll plow through. But we worked together on a startup before this, and we were acquired by a large company, Nike, where we were in the data engineering team. Have any of you guys been in data engineering at a large company before? So it's sometimes a little bit hard to be the bottleneck to everything. We were always the last people between some cool advertising team trying to get something done or some product team trying to understand their product. So we tried to build a company now, FiveOneFour, that is aimed at solving that problem. And we took a lot of inspiration from the developer frameworks that we see and love, like Node. So we essentially have 3 products that we built. The first one is Moose. Moose is an open source developer framework that any of you can use to do data engineering tasks, much like you would do software engineering. It's got a lot of the same paradigms, and I'll show you a little bit of it later. Boreal is how we make money. It's our cloud hosting platform. It includes ClickHouse. Thanks, mate. Then the last one is kind of where we're experimenting, which is Aurora, which is our AI-assisted data engineering. So how can we get our customers into OLAP and ClickHouse a little bit easier, and how can we make the data that they have there more valuable to them? So the big thing that we found is that a lot of our clients are trying to do these data-intensive bits of programming. They're trying to create user-facing analytics. They're trying to create data pipelines. They're trying to show AI to their product. Or they're trying to build what we call functional data warehouses. And all of those kind of suffer from that arcaneness that comes when you don't have types everywhere and when you don't have developer frameworks to help you out. And we tried to solve that arcaneness. We usually see this, what we call like the dilemma of OLAP hit our customers. So we see them say, hey, I've got Postgres. It's great to use. I can do everything locally. I can test stuff. And then they build their OLAP analytics application on top of these OLTP databases, and then very, very quickly they don't scale. Very, very quickly it starts hitting production. Very, very quickly it starts to reach its limits. And so a few months into their project, just as it starts to show value, they decide that they need to re-architect and move everything to OLAP. So I guess we wouldn't all be here if we didn't have a little preference as to what we would do for OLAP. But essentially what we want to do here is build a data store that is meant for these type of applications that these customers are using. So we want something that'll allow for user-facing analytics. We want something that'll allow for AI. We want something that'll allow for these dynamic analytics. And there's some things that are difficult about OLAP, especially if you're not working with ClickHouse. ClickHouse is great because it works locally very beautifully, and it's got a good developer experience. You'll find that isn't always the case with all of the OLAP stack. The hard thing about ClickHouse is that it doesn't live alone. You have to get stuff into ClickHouse. Like for the data applications that we see, there's usually some sort of ingress, there's usually some sort of streaming, there's usually some sort of streaming function before you get it there. And that can be difficult, especially difficult locally. So the corollary of not having our typing, not having our developer framework is that there is so much boilerplate for us to work on. There's so much painful local developer experience, and it's very, very difficult for us to use Git-based CI/CD and do all good software best practices. So we built Moose, our open source dev platform. It's got like pretty easy abstractions. You build data models in TypeScript or Python. It'll create all the data infrastructure that you need and connect it. It'll build your ingest servers. It'll build your Red Panda topics. It'll build your ClickHouse tables. It'll connect them all. We had a mate here from Temporal. It'll even start working with your temporal scripts as well. No more boilerplate, everything works locally, and it's native to your software development lifecycle. Whenever you push to Git, you can push to our cloud hosting as well. One of our customers, F45, do you guys know F45, the gym? So I think we get hundreds of thousands of must be millions of heartbeats per day through our software on this. Tens of thousands or hundreds of thousands of athletes as well, so it's cool. Their head of engineering said that by using Moose, they were able to boost their developer speed on analytics features by 10x, and that's before we did any AI ML. This was just by using our developer framework. But sometimes our customers need our support. We started by, I think we got a few forward deployed engineer type folk in the audience here. We started by using forward deployed engineering, and now we're trying to turn some of the work that our forward deployed engineering does into self-service AI agents and MCPs. We were thoroughly inspired by the work that the ClickHouse team did with MCPs. It was incredible to see, and we'll show off a little bit about how we are using and hoping to use MCPs in the future. So the first problem we wanted to solve in relevance today is how do we get our customers' data into ClickHouse? And essentially, we are doing it right now by using Aurora, which is our AI agent. We start by chatting with a supervisor agent saying, hey, what do we want? The supervisor agent builds a spec, and it sends work to all the worker agents, and they build Moose primitives, which we can run locally. That all makes a whole bag of sense, right? I think it'll probably make a lot more sense if I actually show you. So let me get up and running. Is this too small? Can we see? A bit bigger? There we go. OK, so like the BAML team said, AI is a little bit squishy, and Anthropic has been having a rough couple of days. So this demo will work or it won't based on Anthropic's availability, and if it doesn't, we have a video. But let's try our best anyway. So the first thing I'm going to do is run our Moose developer server. This spins up all of our infrastructure locally. As you can see, we spun up our ClickHouse, our Red Panda, everything we might need. So now any of the primitives that our AI builds, we can test it live to see how it's working against the infrastructure. The next thing I'm going to do is I'm going to call. So it's so difficult to type when you're demoing live. I'm going to call our agents, and they're going to ask us, what are we trying to build here? So there's three main things that we're trying to do. Either we're building an app, we're trying to build a functional data warehouse, or we're trying to do something random, completely off the wall, and that often happens in data engineering. We'll do functional data warehouse today. And so let's do something that's a little bit more difficult than usual. We'll try a more difficult demo here. So we'll scrape one of Coinbase's APIs to get a list of cryptocurrencies that they support. And then we'll hit another Coinbase API to get details about all of those cryptos. This will be something on the order of thousands of data points a minute. So we'll see how it goes. I won't craft the prompt live. I'll just copy paste the one I tested earlier. But essentially, it's grab data from that API, use the other one to get the details, and here are the details about its rate limiting. So do you need any filtering? I don't know what these questions are because the supervisor agent generates these questions, the minimum questions it needs to create the specification, so we'll see what it asks. Do you need any filtering capabilities? No. Do you want any sorting? Yes on time. We'll do a time series. How will the user interact with this? Through an API. And does the Coinbase API require authentication? No. OK, so now our first agent is going to try to do that job. This is the supervisor agent, and it'll build a specification object. Here we go. So we can see that specification, and we can approve it. I'll show it to you in a little bit more detail. What is the expected update frequency? Every 5 seconds. All the specific fields, yes. What is the data? All time. OK, now I will tell it that we don't need to ask more questions. I apologize for that. We have a very hardworking supervisor agent.
Very detail-oriented.
Detail-oriented indeed. Okay, so this is the new spec. Would you like to refine the specification further? No. There we go. So as you can see, this is the spec it wrote. It's going to send this spec to every one of those agents, so they're all working on the same source of truth. If one of those agents asks me further questions, the spec will be updated and will be sent to all those people. So we see the first agent is the script agent, and it did its job by creating a temporary script here to grab some sample data. And as you can see, there's a lot of sample data because there's a lot of data in this example. The second thing we'll do is build a data model from here. This is a typed Moose data model. We should chat about this. And this spins up the first chunk of architecture. As we can see, this is not a saved one, so it's only going to be building a topic and an API endpoint. It won't be building a ClickHouse table. If I do Moose ls, I can see that it built that data model. It's now asking me, do I want to apply any transformations in creating that kind of saved persisted data set? And I can see from here, and from running this demo 5 times to practice, that there's no timestamp here, and I want it to be a time series. So I'll do add a timestamp field. So now it's going to create a timestamp field in the destination, and the streaming function from the first data model to the second data model will add that data in. So now the data model agent is working on building that flattened data model. Here we go. That flattened model is right here. And as we can see, it has a timestamp. If we do Moose ls here, we can see that it actually built a ClickHouse table for us according to this specification. The next thing that it's going to work on is the streaming function. How do we map the data as it was received to the data as I want to present it, as I want it to live in my OLAP database? And this was a really cool thing. LLMs are fantastic at this because they're both strictly typed. It can easily map one to the other, and it can easily transform one to the other. So if we look, this is the streaming function that runs and does those transformations for us. The last thing it'll do is build a script that'll periodically hit the data. This is now outdated. Our newest version uses temporal for this, but this is the old demo. So, well, the new demo with the old feature. And so soon it won't have to build this at all. It'll be done within our temporal workflows. So it's going to build that script for us. And soon we should start seeing the Moose dev server going absolutely crazy, or it'll fail. If it fails, this is a proper agent, so it'll see the failure message. It'll send it back to the agent, and the agent will get that as additional context to be able to try that. Oh, looks like it succeeded. So as we can see, that script ran, the QA agent passed, and now we have got like a little reporter at the bottom that said these agents built these things in these locations. And cool thing about being in an IDE, I can like click into any one of these and just open up that if I want to edit it as I go. So it actually tells me to restart my infrastructure to run the cron, so we'll try that.
What is that command?
Oh, it was Moose dev, and for some reason it bounced a bunch, but it read it just fine.
I didn't know if you had an alias.
It's Moose dev. That's a very excited Moose. So here it's running Moose, and we should get more data through now. But as you can see, if we open up our local ClickHouse, thank you for local, we can have a look and we can see a whole bunch of data in the local ClickHouse from this. And if we put this in our GitHub repo, we can one-click deploy it to Boreal as well. So we were able to have a pretty easy English conversation with our AI to build a really scalable data infrastructure. This is a bit of a contrived example. It's 2 APIs working together, but you can use this with multiple APIs to get data from your HubSpot, or you can use it to get data from your databases and get it into ClickHouse. Whatever you're trying to do, these agents can help, and they can transform the data in the way that you want. I think we've followed some of the best practices that Bamel spoke about of having small agents that do tiny things testably and well, although I'll be chatting with them later to see if we can use their types. I think that's cool as. But yeah, that's the first kind of AI demo I wanted to show you guys. Any questions that you guys have? Yeah, I mean, the whole point is you should easily be able to do data engineering. And you should not have to be a data engineer to do data engineering. A software engineer should be able to do it.
We're all about mere mortals
Yeah.
test.
Yeah. So we have, you can write in TypeScript, you can write in Python. I mean, you can have a look at any one of the files that the LLM wrote. They're all pretty easy to understand. Like they're all, like the streaming function is probably the most complex thing here, and it's not that hard to understand. So the whole point of Moose is that it allows you, as a software developer, to build scalable data engineering stuff easily.
So that works great locally, but what if you need to deploy it? This is like a completely different flow. Like what if you need to turn this into some like Kubernetes cluster or set up Terraform rules?
I promise he's not an employee. Thank you very much for that question. We have essentially like DIY open source that you can use to deploy it yourself, or we've got our Boreal managed service where we can link to your GitHub, and whenever you push, it'll spin up an entire infrastructure. For some of our largest customers, we do like forward deployed engineering work to help you do that all on premise, but that's for very large, like we're talking huge data systems, but usually it's either doable yourself or easily one-clickable with Boreal. And ClickHouse has been especially easy to manage on Boreal. It scales very, very well with the fluctuating API requests that our customers get on their data. Okay, cool. That's the first half. How do we get data in real nice? The second half is a little bit more experimental, and it's how do we generate the most value from the data that we have in ClickHouse or in Moose or in our OLAP system. And this is tough. Like the whole point of our company is to get data there, and it's sometimes hard for a VP of engineering to imagine what it's like to have a OLAP system that's completely set up for their analytics. So we've built a MCP server that allows you to speak in natural language with your ClickHouse data. It can interrogate the Moose data models for metadata about the data. Like, have a look at this data model. There is a lot of metadata here. Oh, sorry, there's a lot of metadata about types, etc., that could be useful. And what we're able to do is expose that to the MCP so that you can essentially ask plain English questions and get real analytics back. One of the cool things that we can do, though, is that once you find a question that you find especially analytically exciting, we can pretty much in one click build you a scalable egress API that's type safe on the back of ClickHouse that allows you to build a kind of scalable interface for that query. So I'm not going to show a live demo of that, but I will show a live conversation that I did have with Anthropic earlier today. The one reason I won't ask this is because this is based on fitness data that we have, and we don't want to go into too much detail about that, and we don't want it to accidentally talk about users or something along those lines. So as you can see, I asked it a question of, does visiting multiple gyms reduce churn? Like there's no more plain English analytics management speak than asking about churn and asking about a variable. And it was able to produce for us a pretty nice little report telling us, hey, how many members go to multiple studios? How does it affect it? It even gave us some key findings about this. But then the cool thing is that if we click any one of these, it gives us the query that it used to create it. And if we click into the code here, we can see that it generated the code to show this off. So what we're able to do is combine that query and that code to build you a kind of scalable analytics on the back of this ad hoc query. So we're able to do that in the order of minutes, where it used to be something that took sprints to do. Our champion at F45 said that now the bottleneck is how fast their product team can come up with new analytics, which is where we want to be. So I'll happily show more of this MCP later. If any of you want to see more of it, please just hit me up after the presentation's finished. Any questions about the MCP side of things? Do we all know what MCPs are? I'll give a 10-second spiel about that, and then we can cede to the last guest, which is essentially the user can use whatever tools they like to speak with their database with MCPs. So the ClickHouse and the Moose MCPs sit on top of ClickHouse, and you can interact with Claude like I did, or you can interact with Cursor or any other client that supports MCPs, and you can interact with your LLM with all the data that's available there. So it is essentially exposing the data from that system to your LLM. Yeah, the first time I tried it, I found myself just having long conversations exploring random parts of our Clickstream website data, and I found it absolutely intoxicating. I'm sure as soon as you guys try it, you guys will love it. I commend to you all the open source ClickHouse MCP to try out. It's a great example. And hit us up if you want to try the Moose version, which also takes into account the rest of your data infrastructure. Thank you very much, team. Really, really appreciate it.